All right, everybody, this is Dr. B. We're back here again tonight. Going to try it again. A bit of a bad hair day today, so I got the hat on. And we're going to take a look at protons, neutrons, and electrons. And the way we're going to do it, a little bit different than we did it last night. We're actually going to work some problems, the types of problems that you'll see on AP Chem exams or the MCAT or something like the NEET. And if you're in high school, this stuff's going to be really useful for you as well. So let's get started and work some of these problems here. So let me go over to my screen. There we go. And this is the first problem that we're going to try. So when you look at this problem here, everything you need to know to solve this problem is in this box right here. So if you got this information here, you should be able to solve these. So take about 30 seconds to get started. I'm going to check in on the chat, see if anybody's here, and let's see if you can do this stuff. This is modeled off a general chemistry exam at the university level. All right, so we're looking at an element with atomic number 16. So we have this atomic number 16, and they give us the mass number 32. Hey, Kubar, good to see you again. If you have atomic number, that equals the number of protons, and the atomic number, that's the whole number, right here above the element symbol. It increases by 1 as we go across the periodic table. So we're looking for 16, which is down here, atomic number 16, that is sulfur. And since the atomic number 16, protons 16 as well. That's all there is to it. How about how many neutrons does it have? Well, we know the mass number's 32. We just figured the protons out. That's 16. So something plus 16 equals 32. 16. That's how many neutrons it has. So you can see if you have this information here, you're in really good shape. How about electrons? And the key here, neutral element. In all of the elements on the periodic table, they're neutral. They don't have like a negative or a positive sign after them. So these are all neutral on the periodic table. Protons and electrons are equal, so we have 16 electrons. And so when you see this here, I have 16 for everything, but it doesn't have to be that way. It just worked out for this. But this little table right here, that has everything you need to know. So as we do problems and as you think about learning chemistry, probably one of the best ways to succeed on exams and tests, and everybody's stressed out about that, having that big exam that so much rides on. The best way to prepare is actually to work as many problems as you can, similar to the one on your exam. So that's kind of what we're trying to do here. So let's try another one. This one is from AP Chemistry, similar to an AP or an IB Chemistry question. Take a look and see if you can do this first part here, part A. So it says the element has an atomic number of 8 and a mass number of 16. So we first need to identify the element. Well, 1, 2, 3, 4, 5, 6, 7, right here, 8. So the element, that's going to be oxygen. And it's in its ground state. So how do you write an electron configuration? So here's how we could do that. This is the way I like to do it, probably the quickest way to do it as well. So we know oxygen has an atomic number of 8. It's going to be neutral. It's in its ground state, so it's going to have 8 electrons. What we want to do is distribute those 8 electrons around the nucleus. That's how we figure out the electron configuration for an element. So if you think of it this way, you could say we have 8, so we start with 1s1 and then 1s2. So we have 1s2. Here's some fireworks in the background here. 1s2, but then we're full here. So we come back over to the second energy level, 2s1, 2s2. We've used 4 out of the 8. Now we're in the 2p's. So we have 2p, 1, 2, 3, 4. That gets us to oxygen, and we've used all 8 of our electrons. So you can see that when they're asking us to identify the element, if we can figure out the number of electrons, then we can write, it's really a lot of fireworks outside my window. That's very interesting. We can write the electron configuration if we know the number of electrons for the atom. So now here's the hard part. Explain why the mass number of this element is not a whole number. And this messes students up quite a bit. The reason is there are different versions of these atoms. So I'm going to jump over, let me grab this here. And I'm also going to put this in the chat. You might find this very useful. There we go. And I'm going to open a browser, if I can do that from here. And this is a free app that I use quite a bit when I'm teaching with my students. So hopefully you can see the app here. And we're going to build the atom. So we're doing oxygen. We said oxygen had 8 protons. 1, 2, 3, 4, 5, 6, 7, 8. That makes it oxygen. We said it had 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. It's a neutral atom now. Charge is 0. Its mass number is 8. But if we keep adding neutrons here, right now it's not stable. We add neutrons. There we go, 7, 8. Now it's stable. So this is one version of oxygen. If we add another neutron, it's still stable. If we add another neutron, it's still stable. So there are different versions of oxygen that are stable. If we keep adding neutrons, though, it becomes unstable. But we have different stable versions. Those are called isotopes. And when we take the average of those masses, because each of these neutrons has mass, that's what makes it on the periodic table not end up to be a whole number. So let's go back there to our periodic table. So it's because we have different neutrons, we get isotopes, and that makes it so the mass number is not a whole number on the periodic table. All right, let's go do another one here. Do you guys have any questions for me about what we're doing here? If this is helpful or not helpful? This is one that very similar to a question on the NEET exam, real popular in India. See if you can figure this one out. You have all the information you need right here. Oops, something happened. Where are we at? Right there. Okay. I did it again. Okay, so here, what we're looking at is we know the number of neutrons and we know the mass number. So we can start there. We could say we have 20 neutrons and the mass number is 40. So how many protons do we have? 20 plus 20, that equals 40. So we have 20 protons. And determine the atomic number of element X. So we know that it has 20 protons, and the atomic number, that's just 20, because the atomic number is the number of protons. I thought they were trying to trick me here for a moment. Yep, Kubar, you got it. Excellent. All right, so this is something you might see on the NEET, but they do put a little harder stuff on there as well. So let me transition over to that. And whenever you're talking about neutrons, protons, electrons, you kind of always get into trying to think about the atom and electron configurations as well. So always try to imagine the nucleus with protons and neutrons and then the electrons around it. That really will help you kind of put a context around this. So let's try this one. Write the electron configuration for the neutral element of X. That was the atomic number 20. So 20 electrons in its ground state. So if you use this, right here is 20, that's calcium. Can you write that electron configuration for calcium just using the periodic table? That's kind of hard. But if you can do this, chemistry gets a whole lot easier. You will do very well on exams. So start here with your 1s, 1s1, 1s2, down to the second energy level. Hey, Nick, thank you. So at 2s1, 2s2, we've used just 4 of the 20. Go over here to 2p, 1, 2, 3, 4, 5, 6. We've used 10. Back to the third energy level, 3s1, 3s2. We've used 12. We do our 3p, which we said has 1, 2, 3, 4, 5, 6. And finally, we end up with 4s1 and 4s2, which is our calcium. That is the electron configuration for element 20, which is calcium. But they want to know which electrons are in the outermost energy level, the valence electrons. And the way you do that is here's the first energy level, here's the second energy level, here's the third, and that 4 is the fourth energy level. These are the valence electrons right here. They're in the highest energy level. So if you can remember that, you're in good shape. And Kubar, you got it right with that electron configuration there. Very nice. Let me show you how this would look here. So you'd have your nucleus, then you'd have your 1s2, and then here's 2s2, and then the p's, here's your 2p6, these 6 here, oops. And then you go to the third energy level where you have your 3s2 and your p's, 6 of those, and you end up on the outside with your valence electrons, your 4s2. Those are the ones that form chemical bonds. So these are really important in chemistry. You'll hear about valence electrons over and over on exams. Your teacher will mention in class, whenever you talk about bonding, you'll use that as well. All right. How are we doing here, everyone? So why don't we do one more of these? We're at about 12 minutes, so 15 minutes or so of this. You really don't want to study in big chunks of time like that. You want to do small chunks, take a break, come back, keep doing that. That rest after about 15 or 20 minutes, real important for memory retention. Farid, that's a good question about valence electrons from each subshell. Typically with a Lewis structure, you'll figure out how many valence electrons for each atom that they offer to the structure, and then you'll distribute them in the compound. So you're really kind of looking at the valence electrons from each element, but then that 3 minus, that makes it a little more complicated. That means you have 3 additional electrons involved as well. So I'll have to do a stream on Lewis structures. We can get into that. That's good stuff. All right, let's do another one. I think this one here Here is, yeah, this is the last one. This is on the MCAT, which a lot of people have to take to get into medical school. So kind of an interesting question. We'll just really look at the first part of it here. So you have this carbon-14, and then you have carbon-12. You may have heard of carbon-14 dating. They use it to figure out about fossils, how old these different fossils are. So see if you can answer this question right here. Because you have the mass number and you have the atomic number. So try to remember that first chart we used. Take about 30 seconds. I'm going to read some of the chat here. All right, you guys all seem like you know what's going on. You're pretty quick. So for carbon-14, atomic number's 6, so 6 protons. And then electrons, they're saying a neutral atom again, like the elements on the periodic table, they're all neutral, no negative or positive. So electrons equals protons, like we said before. That's why it's neutral. Protons are positive, electrons are negative. And then neutrons, we said protons plus, let's write it like this. Protons plus neutrons equals the mass number. So we have carbon-14, that's the mass number. Let's write down here. We don't know the neutrons, but we know we have 6. So 6 plus 8. So we'd have 8 neutrons for carbon-14. That makes sense. Protons and electrons, yeah, that makes sense. Okay, so that's pretty much that. I do want to show you one thing here about why carbon-14 is an isotope. So let's jump over to this here. If I can copy it. There we go. And I'll pull this up here. This is another one of those physics things. And I'll also put the link here for you in the chat. So if you want to try that, you can try that as well. And display my screen. And so you could, if you want, so what they're asking us is why it's an isotope of carbon and why does it differ from carbon-12. And really, when you're building these atoms, so let's make carbon here. Atomic number 6, we put our 6 protons in here. Protons are positive, so right now it's a positive ion. There's carbon. Let's put 6 electrons, 1s2, 2s2, 2p. Oops, I put too many. There we go. 6 electrons, 2p2. So when we look at this right here, right now it's going to be unstable because we don't have any neutrons. We add 6 neutrons, and it's stable. That's carbon-12. We add 7, that's carbon-13. 8 is carbon-14. So these are isotopes. The only reason we call them isotopes, they just have more protons, more neutrons, I should say. But they're still carbon. They just have more neutrons. That's the only thing. I think we're going to wrap it up right there. That's about 20 minutes. I appreciate everyone that's come here this evening to watch. And I think I'm going to do streaming. In the chat, if you have a moment, what do you think about working problems like this? Is this a useful way to do it? Or is it better to kind of do it like I was doing before, where I just go through and explain concepts and do some practice problems? So I'd really like to hear what you have to say about that. And I'm going to go ahead and sign off here. I'll leave the screen up and keep the chat going for a few minutes. This is Dr. B. Thanks for watching.